systems of equations, and that method is called elimination, or it's sometimes called the addition method as well. Alright, so here's how it works. So when you have two equations and you have one variable that are opposites, right? So we have positive 2y and negative 2y. This is really where the method comes from. So because these are both equal, we can add two equal things together and the equation holds. Okay, why would we want to add these? Well, if they're opposites, 2y and negative 2y, when you add those will cancel. So we'll end up with x plus x is 2x. 2y and negative 2y cancel, so we end up with no y's at all. And then 2 plus 6 is 8. And then we're left with 2x equals 8, which we can easily solve for x by dividing by 2. We find out that x is 4. And then just like in previous methods, you substitute the 4 back into either equation to find out what y is. So if I take the first equation and I substitute a 4 in for x, and then solve for y, so subtract 4 from both sides. Oops. And then divide by 2. We find out that y is negative 1, and so we find the solution is the ordered pair 4, negative 1. So it can be a faster method than substitution, and it can be easier depending on which equations you're given. So let's look at another example where we need to do an additional step. Okay, so in this step we were given opposites. In the next equation we don't have opposites yet. So step one is to multiply one or both equations by a constant to make variables with the same coefficient and opposite signs. Right, we want one to be positive and one to be negative. Okay, so I need to decide what variable I want to get rid of, and it doesn't matter. I can get rid of x or I can get rid of y. So let me show you both possibilities. So I'm going to rewrite my equations here. And I think first I will try to get rid of my x's. So I have 2x and I have x. So right now they have the same sign, and one has a 2 and one has a 1. So if I take the second equation and I multiply every single term in it by negative 2, my x's will have opposite signs. So let's go ahead and do that. So negative 2 times x is negative 2x. Negative 2 times minus 4y is positive 8y. And then negative 2 times 6 is negative 12. So let me just rewrite that top equation. So now my equations, they're still the same equations, they just look differently. And substitution method, step 2, is to add them together. Right, so negative 2x, positive 2x, those cancel, which was the whole point. 8y and y is 9y. And negative 12 plus 3 is negative 9. And if we divide by 9 to solve for y, we find that y is -1. So I could go ahead and substitute this back in to either equation to find out what x is, or I'm going to show you that I could have done the exact same method but gotten rid of the y's instead. So let's start with the two equations again. If I wanted to get rid of the y's, notice they already have opposite signs, so I don't need to worry about multiplying by a negative. However, I want to multiply this equation by 4. Alright, and I'm going to move this all right down here. So I'm going to distribute the 4. So 4 times 2x is 8x. 4 times y is 4y. And 4 times 3 is 12. And here's my second equation. And I'm going to add these together. So 8x plus x is 9x. These two cancel. And then 12 and 6 is 18. And then we can solve for x. We find out that x is 2. And you want to make sure you write your answer as an ordered pair. Okay, so in this case, when we solve for x and when we solve for y, we multiplied one equation by a constant. Sometimes you have to multiply both equations. Alright, so first thing I'm going to do is decide whether to get rid of x or y. So I think in this case I'll get rid of the x term. Alright, so I want to multiply so that my x terms have the same coefficient with opposite signs. Right now they have the same sign. Okay, so I'm going to multiply one of the equations by a negative, and it doesn't matter which one. Okay, and 4 and 3 don't have anything in common. There's nothing that goes into both of those. So I'm going to multiply that top equation by 3 and the bottom equation by 4, and that will make both of my coefficients 12. Alright, so I'm going to go ahead and distribute -3 to the top equation. So -12x, -3 times 6 is -18y, and -3 times -10 is 30. Alright, and then I'm going to go ahead and distribute the 4. 4 times 3x is 12x. 4 times -5x is -20, and 4 times 21 is 84. So I'm going to go ahead and add these together. Alright, the x's will cancel. -18 and -20 will give me -38. And then over here, I get 124. Divide both sides by 38. And did I do this right? Okay, so hold on one second, let's just back up because I think I made a little math error. Oops. There we go, that's better. Alright, divide by -38, and y is -3. Okay, and then you can use the same method again with y's, or you can just substitute y back in to either equation. Alright, and then solve for x, so add 18. 4x equals 8, so x is 2. Okay, so my solution written as an ordered pair is 2, -3. So now go ahead and try the 3 examples on the bottom of your worksheet.